In this section, we're going to look at solving problems using quadratic models. And we're going to focus on just one example. So the relation p equals negative n squared plus 580n minus 46,000 models the profit p in dollars for a concert, where n is the number of tickets sold. Determine the number of tickets that must be sold to A, maximize the profit. We have a graph where n is the number of tickets sold and p is the total profit. And we have a parabola that opens downwards since the a value is negative. So we want to determine the number of tickets that must be sold to maximize the profit. So we're looking for n, and our maximum profit is where the vertex is. So we're looking for the axis of symmetry. We have two ways to find the axis of symmetry. One way is to factor, solve for the zeros, and then find the axis of symmetry. But our second way, which works out much better, is to use symmetry. So recall, for symmetry, we're going to let the profit P equal negative 46,000. So we get negative 46,000 equals negative n squared plus 580n minus 46,000. If we add 46,000 to both sides, we end up with 0 equals negative n squared plus 580n. Next, we need the common factor, so we take out the negative n, and we're left with n minus 580. So what we have now is the y-intercept. This is where n is equal to 0. And we have its corresponding point, where n is equal to 580. These are not the zeros. They would be points where you would have negative profit. So it would be the y-intercept here, negative 46,000, and its matching point somewhere over here. But they're still equal distance from the axis of symmetry. So now we can find the axis of symmetry. So n equals n1 plus n2 divided by 2. And this tells us that we have an axis of symmetry of 580 divided by 2, which is equal to 290 tickets. Therefore, 290 tickets need to be sold to maximize the profit. If we wanted to find the maximum profit, we would take 290 and sub that back into our original equation. P equals negative n squared plus 580n minus 46,000. All right, question B. What are the number of tickets that need to be sold to break even? So remember, the break even, that means your profit must equal 0. You don't make any money, you don't lose any money. So for this example, we'll let P equal 0. So we get 0 equals negative n squared plus 580n minus 46,000. So next, we can use the quadratic formula. And we get n is equal to negative b, so negative 580, plus or minus the square root of 580 squared minus 4 times negative 1 times negative 46,000. All over 2 times negative 1. If we simplify, we get 580 plus or minus the square root of 152,400 all over -2. And therefore we get our first root to be 580 plus the square root of 152,400 over -2, and our second root to be 580 minus the square root of 152,400 over -2. We sub that into our calculator, and we get n1 is equal to approximately 485.2, and n2 is approximately equal to 94.8. So again, if we think of our graph, we just found two zeros here and here, both positive, which means that the company will break even if they sell approximately 95 tickets or 485 tickets. All right, question C says obtain a profit greater than $28,000. So again, if we think of our graph up here, we want to see if we can get a profit that's higher than $28,000. So anything that's above 28,000. So we're going to start off by saying let the profit equal $28,000. So we're going to find these 2 points where that horizontal line hits the parabola at 28,000. So we let P equals 28,000. So we get 28,000 equals negative n squared plus 580n minus 46,000. Subtracting 28,000 from both sides gives us negative n squared plus 580n minus 74,000. Next, we need to solve this equation. It would be tough to factor these large numbers, so we're going to use the quadratic formula. N equals negative 580 plus or minus the square root of 580 squared minus 4 times negative 1 times negative 74,000. All over 2 times negative 1. So therefore we get n equals negative 580 plus or minus the square root of 40,400 all divided by negative 2. So we have n1 equals negative 580 plus the square root of 40,400 all over negative 2, and n2 equals negative 580 minus the square root of 40,400 all over negative 2. And we'll carry that over to here. So we get n1 equals, so we get 189, or approximately 189.5 for n1. And for n2, we get approximately 390.5. So these numbers represent the number of tickets that you would sell to get $28,000 as your profit. So therefore, they need to sell approximately 190 to 390 tickets to earn a profit greater than $28,000. So notice there's two types of problems that we'll have when solving quadratics. And in summary, we're going to explain these two. So do you need to determine a max or minimum? If yes, then you should locate the vertex of the quadratic relation. So the method we're going to use to find the vertex is going to be symmetry. If it's in vertex form, you already have your vertex. And if it's in factored form, you can already find your zeros, your axis symmetry, and your vertex. So we're going to use symmetry if the quadratic relation is in standard form. The second type of questions we get, do you need to determine the x values for a certain y value? Or are you given a specific value of y? Any number including 0. So if yes, then you should solve the corresponding equation. When solving the corresponding equation, we have two methods. First of all, we rearrange it so that we get ax squared plus bx plus c equals 0, and then we have a choice. We can either factor and solve for the roots or use the quadratic formula to determine the roots. So quickly one more time, if you're trying to find the max or minimum, we're going to use symmetry. If you want to determine x values for certain y values, then we can either factor, if possible, or use the quadratic formula.